Hello, everyone. I'd like to start off by saying thank you for attending our Artec LEO webinar. My name is Matt Filkins. Today I'm going to be joined by Head Applications Engineer from Reality 3D, Stuart Bell, and Applications Engineer from Geomagic Software, which is a division of 3D Systems. Reality 3D, we are a reseller of Artec 3D scanners and Geomagic Software, as well as being a service bureau for 3D printing and scanning in Denver, Colorado. We have 6 years experience in selling Artec products and are considered by Artec to be a gold certified reseller for exceptional product knowledge. Sorry. Today we're going to be demoing the brand new Artec LEO in conjunction with Geomagic Design X to reverse engineer an SUV's exhaust system to highlight the ease of use and speed of the Artec LEO, as well as show off the reverse engineering capabilities of Design X to solve complex problems quickly and easily. We wanted to do an industry-specific webinar for our EDU clients because Artec and Geomagic understand the value of putting these tools in students' hands early. Highlighting some of the discounts that are available through Artec. Automatically, you get a 10% discount off of MSRP and 20 free licenses so students can all be working on the same project in the lab or the classroom at the same time. 2 years of free software updates, and Reality 3D is offering free on-site training where we send our techs to your facility to train up professors or the lab engineers. Geomagic has several bundle options available for students and EDU clients. To highlight it, the top of the list is the Geomagic Classroom Elite Suite, where you get 20 free licenses of Design X, 20 licenses of Control X, 3 years of maintenance, unlimited support for $20,000. Just to let everyone know, one license of Design X for regular customers is $20,000, so it's a fairly strong value. There are packages that we can tailor to your needs, though, if you don't need that many licenses. I would now like to kick it over to Stu Bell to go over some of the highlights and specs of the LEO and Design X before we proceed with the demo. So let me make Stu a presenter here, and we'll get going. All right, there you go, Stu.
All right, thank you, Matt. Hello, everyone. Thank you for attending today. I did want to point out that if you look in your toolbar, your GoToWebinar toolbar, you will see a handout that gives further detail on the Geomagic education bundles. There's also a handout for the LEO. That being said, let's dive into introducing ourselves to the LEO. The LEO is the newest handheld scanner from Artec. It is completely wireless, which those of you who have done 3D scanning before know how cumbersome, how much of a hassle it can be needing to be connected to a laptop. With the wireless, built-in swappable battery, the LEO is very portable and really easy to use. It has an industry-leading field of view, a lightning-fast 3D reconstruction rate, a first-of-its-kind automatic onboard processing. It comes with Artec's hybrid geometry and texture tracking, which means you don't need proprietary dots for your scanning processes. And this is one of my favorite features, which is the built-in onboard touchscreen. This allows you to quickly and easily review your data as you scan, so you can ensure you're getting all your data, all your object as you scan in. Now, this really is a scanner that was built for all user levels in mind to scan with confidence and speed. And this includes a freshman, if you dare let a freshman touch the tool. While the scanner, while the LEO, like most 3D scanners, is line of sight, you have to be able to see all the way around the object. Its technology really allows us to overcome traditional challenges in 3D scanning. Scanning black, shiny objects, scanning in direct sunlight are really a lot easier to scan than they ever have been before. Uses and applications. This is a professional grade 3D scanner. As some of you may know, scanners are geometry neutral. This will scan everything from a 3-foot tall fan blade for a reverse engineering application to a sarcophagus in Egypt, or even a human limb for a custom orthotic. The versatile nature of the scanner gives every classroom unlimited options. A little bit about Geomagic DesignX. Geomagic DesignX is an industry-leading scan-to-CAD software. It has the most comprehensive and accurate suite of tools for reverse engineering and digital documentation of physical parts. A 3D systems company, as Matt previously mentioned, Geomagic's software, DesignX specifically, delivers seamless scan-based design, engineering, and manufacturing. From engineering legacy parts, redesigning broken parts, or to making informed engineering choices that are informed by the physical world, DesignX is the missing link to joining 3D scanning to computer automated design. So that's kind of a quick overview. Let's dive right into the demo. So as Matt mentioned, our demo today is going to be 3D scanning and then going into DesignX. We scanned the underside of an automobile. We will be taking questions during the process. Please feel free. There is a little questions bar also in your GoToMeeting, or excuse me, GoToWebinar toolbar. Enter them there. We'll take time at the end of the demo to do all that. So if you ask your questions, and let's dive into the demo itself. We did do a little bit of this pre-recorded because we did do the scanning itself offsite at a local mechanic shop who was nice enough to let us use their lift. So let me see if I can get that going for us. Let's start the demo by taking a look at scanning with the Leo. I'm using the onboard screen to check my data as I scan, as well as using that same screen to plan my path. Because of the large scanning volume, I can really visualize my data very quickly and as I'm scanning. If you look closely, you can see that we're not using any markers or tracking dots. The hybrid scanning or the hybrid tracking of the scanner allows us to do this very quickly without having to add anything. All right, we're done with the scanning portion. Now we want to move on to the data processing portion. We're going to process the data in Artec Studio 14. Artec Studio 14, we'll do a quick introduction here. We have a top-down, left-to-right workflow. Over here we have all of our processing tools. Down here we have our log window, which is going to just give us our basic information when we start algorithms, things like that. We have our workspace over here, which is going to contain all of our scan information. And then of course our big nice viewer window, which is going to show us our scan information. First step to processing our data is going and getting our data. I'm just going to do a file import, our Leo project. I know that it's project 50. I can set up myself a nice folder here. And we'll do an import on that. All right, we have our data set imported. Let's take a look at it. Right now we are looking at the first scan I did. Looks like we have our texture on. So come over here, toggle to scan color. This gives us a little bit better idea of what we're looking at. Nice, nice. Second, third. All right, I like the look of it. And this last one is a little extra scan. I rescanned this and we'll actually import that data. So I'm going to eliminate that. First thing we're going to do is just so we can verify a few things, just do a quick alignment. When I say alignment, I mean exactly that. What we're going to do is take and make sure all three of our data sets that we have presently viewing here are all put together. They all look in the same orientation. So we're going to align everything to this master data set. Do that by spinning this one around. I'm spinning around just using a shift and mouse click as a command. So I'm going to add a couple alignment nodes, telling the software what I know to be overlapping data points. We'll do 4 in this case, give us a good one. So we'll hit align markers. We like the look of that. We'll hit align. And now we'll add the third data set. As you're watching my screen, you can see as we add data sets, we're actually filling in space. We're going to fill in this space with this nice recording here. Since the scanners are in line of sight, as we previously mentioned, we had to scan this from a couple different angles. Align markers and align. All right, we'll hit apply. Now, I mentioned just a few moments ago that I have a couple extra data sets I want to add to this. Those are another import. I went and did a little extra, gathered a little extra information right along the bumper here to fill in this space and give us wrap up the back side of the car here. So we'll go grab those real quick. Same thing, import Leo project. I know that it's 50.1. Prompt me a little question here. Do I want to save deleted scans? No, I do not. No, thank you. It's going to resave my project for me. All right. Second data set is imported. Very nice. Let's take a look at it real quick. You can see what I was describing here. A little bit of a, these I did it as a what we call continuous scanning mode. So they're already pre-aligned, but they're not pre-aligned to here. So first thing we want to do is get them here. Now I overscanned a little bit, and you can see scanned up and around. So I'm going to save us some time on my algorithms. I'm actually going to just clip this last one out there. I'm really focused on this bottom section here. I want to just get that muffler there, and then the exhaust ports, add it to my data set here, give us a little bit more of that bumper information. So same thing, back into align. Now I already aligned those previous scans, so I'm not going to worry too much about those. I'm going to select them. Just do a simple shift select, mark as registered. We don't want to mess around with those. We just want to add some information. One of the great things about all Artec scanners is we can always add information. The speed, the ease of use is really impressive. And being able to add information, get better coverage on our scans quickly, really makes this a powerful and useful tool. So I'll just do 3 points this time. Should be pretty straightforward. We'll hit align markers. I like it. We'll hit align. Next up, we'll add our last scan set here. Same basic idea. 3 points. I guess I got a nice overlapping feature there. Align markers and align. All right, those are aligned. Nicely done. I'm happy about that, so we'll hit apply. Next up, we're going to move on to making a solid out of this. But first thing we want to do is actually clean out some of the data we don't need. So I'm going to toggle off visibility on everything but my first scan here. I'm just going to go through and manually clip out. We're going to follow this exhaust system here. So in truth, we don't need anything forward of this. We don't need any of the a little bit of the inside of the tire wall, any of that stuff. So we'll just go through. We're going to use our eraser tool. One of the things that I, as a user of Artec, really like is the editing and erasing tools. They're very fast, very intuitive, and really make it so we don't have to process triangles we don't need to process. So just doing a control select there, come here, just using their simple paintbrush tool, what they call the 2D selection tool, and the control to select. A little bit of excess floating out there. Same thing on this side, just paint all on that there. Now I could go through and I could manually clean and really do a lot here, but we want it to look kind of nice too, so we won't worry too much about getting every single polygon out of every single data set. We'll click down into our second scan set and rinse and repeat. Just did a little double click there so I can anchor my viewpoint. So now I'm pivoting around here. That's a nice feature. Artec allows us to better visualize our data. And that's really what we want to be able to do quickly, right? We want to be able to visualize our data, manipulate our data, and make it so our scanning actually increases our workflows. Allows us to do things that we wouldn't do, and if we did by hand, would take us well. Allows us to do those things faster. Get rid of a little bit of a tire here. Clean up small amount of data on the outside there. As I'm doing this, if anyone has any questions, please feel free to throw them in the question tab on your GoToWebinar toolbar. If you can't find that, it should just be a little tab named questions. You might have to expand it. Please feel free to ask. We will take all questions at the end of the session, but if you're thinking of something, if you see something while we're doing it, please feel free to throw a question there. Or if you have questions that come up later on, or you want to talk to us directly, you can always reach us via email by emailing us at info@reality3d.net. That's info@reality3d.net. Moving on to our third data set. There it is there. Just trim out this front portion here. I overpainted a little bit. That's okay. We can always go and just do a Control-Alt paint, and I'm actually going to deselect. I didn't want to get rid of everything up there and be able to see, theorize or visualize where the exhaust comes up here. So get rid of some of that. See just a little bit of the tire here. We'll come through here and paint that. Paint on some of this excess hanging over there. Same thing here. So sometimes when we import the data, I was centered on here. Just use my little fit to view tab there. It allows me to view it here. Picked up a little bit of the ground. Definitely want to eliminate that. Toggle off that view. We don't need to be working on two data sets at the same time. Tire. You can also use our view cube here to give us standard views. A little bit slower, but a little bit more intentional. And that looks good. Maybe come in here. I'm actually going to use another tool here called the lasso select. Just going to draw around these floating data sets, polygons here. Same thing, Control Paint, or Control left mouse click. If you want to be absolutely technical about it, allows me to select all this nice and quick here. Set another anchor, clean out the side here. And our last data set, still using that lasso select, just to show off the other tools that we have in here. I won't use the cutoff or base select because we don't have those. Are for eliminating planar surfaces. I can use a nice lasso select or the box select, which some people prefer, just a simple tool like that. Come over here, we can box select over here. Just adding to my selection, erase it, nice and clean. We're going to exit out of our tool. Turn back on the rest of our scan data. If we look like we're pretty happy with it, I could come through and I could nurse this a little bit more, but let's go ahead and move on to the next step. So step 1 was importing. Step 2 was aligning all of our imported data. Step 3 was to clean up the data. Step 4 is going to be really going to let the computer do most of the work. First thing we're going to do is finish up our alignment using a global registration. Each of these scan sets consists of a certain number of frames. We're going to bring those all into the same global coordinate system, and that's as simple as checking our settings, ensuring our scanner set to what we scanned it with, which was the LEO, and we're just going to click right here for a global registration. All right, our global registration is done. I like what we see here. You can see we just have a little bit of data floating out there, so I'm just going to go through and use my eraser tool because that wasn't quite enough information. That's okay. We'll just clean that up, we've got plenty of information in that spot from the rest of our scans. Same thing on this one here. All right, global registration, we've aligned everything, we've checked it all, we like how it looks. Next up is to take our point cloud, which we're looking at just a point cloud in space right now, and turn it into a usable STL, something we can take into our next step, into our software design step. We're going to do that by going back to our Tools tab. And I'm a big fan of the Sharp Fusion. Fusion is Artec's term for taking our our point cloud and drawing our polygons between it. In this case, it's going to be a tessellation. We're going to draw our triangles. Check my resolution. I like what I'm seeing. Oh, turn on my extra set there. I like it. We'll just hit apply. Well, that's going real quick. I'll talk about some of the requirements that we want to use for the software, specifically the computer requirements. If you look in the lower bottom left-hand corner of my screen, you can see a tab that gives us a readout that gives us free RAM and total memory in use. This is a little stat that lets us know how many resources or how much of that particular resource we're using. The software is very RAM intensive. We're dealing with a lot of big data sets. We're putting it in the RAM, we're accessing it in real time. We strongly recommend 64 gigs or more for you scanning with the Leo. The laptop I'm working on right now has 64 gigs. That's only because as you can see over here in my workspace, we have several large data sets that we're working with here. So we really want that free space, that RAM space there. Next up is our CPU. That's our second most important. RAM is our first most important. CPU is our second most important. The CPU is what makes all the processing go nice and fast. I have an i7 that works really well. Artec Studio really likes the NVIDIA chipset, the Intel chipset. NVIDIA is later on with the graphics card, really likes that Intel. Anything that's going to have that multi-core processing is going to make processing your data a lot faster. Clock speed matters too, but we want those nice multi-core processing. We'll take advantage of hyper-threading. Last but not least is our graphics card. As I mentioned just a few moments ago, the Artec prefers the NVIDIA chipsets. That's going to be your Quadros, your GTX cards if you're gaming savvy. That's what allows us to spin and manipulate our data in space. So lots of RAM, halfway decent processor. As far as the GPU goes, we don't need anything gangbusters, but something with 4 gigs of dedicated memory is going to make a big difference. And that's that. So we'll let this process forward here take just a moment. Now we have a nice mesh, and we have a few things to clean up still. We'll move into our post-processing phase. We still have a few things that we didn't get deleted, some small clusters. I could go through and I could manually delete those using the eraser tool in my editor tab, or I could come over here and I could actually just say small object filter everything, eliminate everything that's 5,000 polygons or less. So we'll just do that real quick. That cleaned up a lot of our little bits of noise, but we still have a few left here, so we will go into that editor tab. Just clean up a few little dangling bits here. We could leave these. They're just going to make our lives a little more difficult. And we certainly don't need them where they are, so we can just clean them up. Once we have that cleaned up, let's take a look at a couple things. So you can see over here in my workspace, I have a new thing called a Sharp Fusion. This has created a separate data set. So we still have our raw data, so I could go through and run this a couple different ways. The Fusion has given me the option. Fusion, remember, is just our Artec term for our point cloud file. It's never going to eliminate my raw data, which I really like as a user. It means I can go back, I can change things, I can add information, as in the case of adding the bumper scans. In this case, let's take a look at what makes up our fusion. Looks like we are made up at about 170 million polygons. That's quite a bit, so we're going to want to run a mesh reduction. I'm going to go back to my post-processing tools, mesh simplification. In this case, I want to hit about 150,000 polygons. I could go by accuracy, a few things, and actually thinking about it, I'm going to go by accuracy. So I'm going to click back here, just go to accuracy. We have a few different options. Go accuracy, best, triangle quantity. I can set that 150,000 and so on. So we'll just go by accuracy and we'll set that to run. Okay, mesh simplification is done. And we've reduced from 160 million to 1.7. So that's pretty good. That should be enough for us to work with. So from here, we have a few choices. We are, of course, going to shoot over to our visiting our guest applications engineer, but we want to look at our other options as well, just so we understand them. We can, of course, just export our meshes. We have the option to export it as an STL, OBJ. STL and OBJ are our most common. So we'll just go find the folder I set up for this earlier, name our file, and we're set to go. If we're keeping this locally, or if we were doing a slightly different workflow, I could just do what we call a direct export. I can actually direct export to DesignX or to SolidWorks. If I'm doing the design work on SolidWorks, I can DesignX or using the Geomagic for SolidWorks module. That's everything I have. I'm going to hand it over to Jeff. Jeff, take it away.
Thanks, Stuart. Hello, everyone. Once again, my name is Jeff Moody. I'm an applications engineer with 3D Systems Software, and today I'm going to be working with the scans that Stuart provided me from Artec Studio. So let's go ahead and get into the demonstration. If you take a look, this is a pretty good scan. They did a really good job cleaning it up in Artec Studio. It kind of shows the underside of the car and gives us a good example of what's already there. So this exhaust here, starting from the catalytic converter here, running all the way back to the muffler and the two exhaust tips here. My job today is going to be creating a new custom exhaust for this car, and I'm going to start up here somewhere. But if I wanted to, I could reverse engineer this thing that's already existing here by simply just selecting the pipe, maybe just a little bit extra of the pipe here up in front, then coming up to the menu option, selecting Insert, selecting Modeling Wizard, and then selecting the Pipe Wizard. Based on my selection, it's going to create a pipe for me in its pre-existing location. So if I go to the next step, it will give me an example of what's already there or what it thinks I want to be there. And I can choose cap the ends to make it a solid part. I can give it a specific size. Instead of 32.77, I can tell it to be 32.5, for example. And then I can tell it to be just a little bit smoother if I kick this over just a notch. Then I'll go ahead and say OK. This will result in a solid body in its current location. So again, if I hide this, this is that current exhaust. And this is all well and good, unless I want this to be a race car, in which case I wouldn't create something that it's existing there. I want this to be as straight as possible to make the exhaust flow as efficient as possible. So to do that, I'm going to start off in this front location here and create a catback exhaust. So I'm going to start on this flange, and I'm going to go normal to this top face here, or normal to this top plane. Then I'm going to left click and drag that front plane down into that flange area. And right about there should do it. And if I zoom in, I now have a front plane in that area. Now that I have a front plane there, anywhere the mesh is intersecting with that plane, we'll create a cross section. And that cross section is going to display as a teal line. Now once I have that teal line, I can use it as a reference to create lines and arcs, which will allow me to recreate this flange. I'm going to go ahead and bring in the sides and bring in the bottom. I don't need any of this extra information. I just need this one area here. To make sure I got the best information, instead of saying take a cross section, I'm going to tell the software to take a silhouette range, which is going to look in an area and not just on the not just in the one plane itself. I might tell it to scoot back just a little bit. Great, and I'll say OK. So here I'll go ahead and hide my mesh. And here I have the outer profile of that flange. So now I just need to apply a couple lines and arcs, and I'll just do that here, one on this side as well. Then I will fillet the two together. Holding Shift, I'll select the first one, then left clicking and dragging. I can dynamically adjust this to match that contour. And it's 45.5, and I'll go ahead and just change that to a round number, 45.5. Wow, let's try that again. 45.5, okay. And I'll resize the ends and I'll just drag them out just a bit. And I'll go ahead and put a symmetry plane or symmetry line down so that I can mirror this to the opposite side so we get the full flange. I'll choose this as my symmetry line, and then I just need to select the entities in which I want to mirror. Then I'll say OK. Go ahead and delete out the symmetry line because I no longer need it. And I'll just go ahead and apply the tendencies really quick so it's a good sketch. Once I'm done there, I can go ahead and fill out the edges. And we see that I got a little bit of a bend over here, right here somewhere. So I'll go ahead and left click and drag again, just to make sure that that's a good fillet. And it'll end up being 10 millimeters. And we'll do that to the other side as well. So again, select this line, select that line, and then force it to be 10 millimeters. All right, now I'll go ahead and exit out of my sketch. Go into the modeling tab. I'll turn my mesh back on, hide my planes really quick, and then I'll extrude this out in both directions. So instead of 2,650 millimeters, it's probably more like 5 millimeters. That looks a little bit better. And in the opposite direction, I might use this arrow and drag it out a bit, and that looks better too. And I'll go ahead and say OK. And here we have our flange. Now, if I want to get the diameter of this pipe, and I want to make it a little bit bigger, so I'm going to use the exact same sketch plane that I used earlier. I'm going to go up to the Sketch tab, and I'll select Mesh Sketch once again, choose this as my base plane, and then I'll offset it out here. This is going to do two things. First, it's going to give me the intersection that I offset at in a solid teal line, and then it gives me this dotted line in the back. The dotted line represents our original base plane, and it's showing us where all of this information is going to be sent back to. So anytime we offset a plane, all of the offset information is sent back to the original plane. So I'll go ahead and say OK. Hide my mesh again. And I'll just quickly snap a circle on here. I'll go ahead and dimension that out to see what it is, to see what it's at. And it looks like 32.8. That's great, but since this is going to be a race car, I now want to turn it into something bigger, right? Bigger is better. 33.5 is going to be good for me, I think. And just to make sure it's symmetric on this flange, I'm going to go ahead and convert entities for the top part and the bottom part, and I'll say OK. That'll give me this black center point that I can then put the center point of my circle to. I'll go ahead and exit out of the sketch, turn my mesh back on, and now we have an exhaust as soon as I extrude this all the way down. So there's a couple things that I need to take care of right now, and I think going right through here is probably pretty good, but I just want to make sure. So there's a couple things I need to do. First, I'm going to turn on the view clip and make sure that I'm not interfering with this top bracket here and this bottom bracket. So I'll come up to the display, select view clip, select set, and then I'll just drag it down until I hit that bracket. There we go. I can take a look. Oops. And it looks like I'm going to clear it. And I did. Great. And I'll just keep going down this pipe just to make sure that I don't run into anything else. Ooh, and there's a problem right there. It looks like I'm going to hit the back axle of the car. Yep, so we'll need to fix that. So there's a couple ways we can do that. I'm going to go ahead and turn off my display. I'm going to edit my extrusion, and I'm going to send it back a couple steps. So the first thing that I might want to do is find out how high this pipe is, how high the original pipe is. That'll give me a good example of where I should be so I don't hit anything. So this time I'm going to offset another plane, and I'm going to do it in about this location here. So holding Control, I'm going to click and drag, and I'll put my plane right here. Turn off my top right and front plane. Come over to the Sketch tab, select Mesh Sketch, and anywhere I'll select this as my base plane, and anywhere that it's intersecting with the mesh, it's going to show me where I can sketch. So I'll go ahead and say OK here. I'll hide my mesh, and here is the height. So okay, that's all well and good. Create a center line here. Then I'll create another circle, the same diameter as our previous circle, which is 33.5. Say OK. And I'll drag that down and I'll put that somewhere around here. Yeah, right there's probably good. Delete out all the information that I don't need. Right click and exit. Cool. Now I can go to the model tab and I can say Loft. I can choose Loft from here to here and say OK. At this point, I can continue on doing an extrude. All I need to do is come over to the extrude option, turn on my correct sketch, choose the sketch loop, and tell it to extrude. And here, I'm just going to step back just a little bit, right about there, and I'll say OK. The final thing that I need to do here is connect this end pipe and this end pipe to this main pipe here. To do that, I am going to use a 3D sketch. I'm going to take another cross section here at the end of the exhaust, and then I'm going to add pigtails onto each section. So to start, I'm going to choose the front plane, and I'm going to go normal to the top plane, extrude this down, or I'm going to offset the plane. Cool. And then I'll take another mesh sketch just so I can find the locations of these circles here. So again, I'll come over to the Sketch tab, select Mesh Sketch, choose my base plane. I don't need this information on the side. I don't need the bumper, so I'll just squeeze that in. Squeeze it in on the other side as well, and say OK. Turn off my mesh, and there are my two exhausts. I'll quickly apply circles to them, dimension them out to see what size they are. 29 and 26, let's go ahead and split that, and let's do 27.5. 27.5. Now our other exhaust, our main exhaust body is 33 millimeters, so if we wanted to, we could kick this up even bigger. We could go to 30 millimeters since we have much larger, or since we have two exhausts at the end of it, the flow shouldn't be affected by the smaller diameter. So I'll go ahead and exit out of there. And now I'll create my 3D sketches. So I'll come up to the 3D sketch option. And this time I'm going to select 3D sketch instead of 3D mesh sketch because I'm just creating simple quick splines. Oh, first what I need to do though is I need to create a sketch on the end of this pipe here. So I'm going to go back into sketch and I'll choose the regular sketch just so I can sketch on the end of this. And then I'll tell it to convert entities, which will allow me to bring the edge of this pipe into the sketch itself. And now I can exit out. Turn these off. Oops, turn that one on. Now I have three different sketches. I'll hide my planes. Then I'll come up to the 3D sketch, choose spline, and just drag this out just a bit. Hit enter, and I'll do the same to the other two. And I know this is kind of hard to see, but right here, drag this out. Same with this. Click and drag that out. Great. So now I got a couple pigtails that I can work with. And lastly, I just need to connect them all together. And to do that, I'll click here, click there, enter, click here, connect it to the opposite side. Great. So there's a couple things I need to do really quick. This piece here, I'm going to add in a third point in the middle of the part. Then I'm going to split it so it makes the transition between this pipe and this pipe smoother. So I'm going to come up to split this one here, likewise this one over here, say OK. Delete out this intersection because it's not great. Then I will, copy this end tip here, and then I'll tell it to blend. So I need to select the points in which to blend to, and it gives me the preview of what I'm looking for. So I'll say OK, hit V, V, and then select the end tips again, here and here, and it gives me that kind of nice contour. I need to do the same at these endpoints as well. So again, I'm going to come down and split. I'm going to first add in a third point here, 3. And let's do that to this other option, to this other line. It's just so I have a midpoint. Then I'm going to come into split, select split, both ends here, select split here, and OK. And then I'll delete out these intersections. I'll come up to blend and select both sides, and it gives me a nice blended contour in 3D space. Select both of these, blend them together as well, and say OK. Now I have 2 paths that it can go down, so I'll exit out of my sketch, and then I just choose the contours to sweep. Come up to model, select sweep, choose this as my profile path. There we go, and then choose the path. Oh, last but not least, this path as well. Say OK. And then just repeat that step one more time on the opposite side. Sweep. There we are. There's my profile, my path. Say OK. Lastly, one more. Do a loft between this and this. Say OK. And at that point, I can Boolean all of these together to make one continuous pipe. Say OK. And now we have a new racing exhaust for our CX90. And if I wanted to, I could just extrude these out to the end. But let's go ahead and select the exhaust that we already have and delete it away. This vehicle is ready to race. So with that, I'll go ahead and hand it back over to you, Stuart. Thank you guys very much.
All right, Jeff, thank you so much. That was a great little demo there. Let's move over to our questions. Any questions we can answer for anybody out there? See if anybody had any during the videos. Don't see anything. Matt, I'm going to kick it back over to you to wrap us up.
All right. Well, we appreciate everyone taking the time to visit with us and check out the Artec LEO and Geomagic Design X. Sorry, our contact information is on the screen here if you want to get in touch with us. I know that maybe scanning the underside of a vehicle is not up your alley. We are available to do custom demos of the equipment with your parts if you wanted to ship them to us. But other than that, if there are no questions, thank you everyone for attending, and we'll be giving you a call to follow up and see what you thought. All right, thank you so much.
Thank you, everybody.